Now, when it comes to writing the radical equations from their graphs, we're going to follow this transformation algorithm as our guide, and we're going to do this by selecting two specific points. The first point, which would be wherever the graph starts at, is going to help us define our C and D values. Now, in some other textbooks, they might call this H and K, and it doesn't really matter what you call it, as long as you understand that the H or the C represents the horizontal translation, and the D or the K represents the vertical translation. The second point, and you can really pick any point along this graph. I would just suggest picking points that are clear and that are not decimals. We're going to use to sub in for the Y and the X with the aim of isolating for the A. Now for the B value here, we're going to deal with graphs that have neither a stretch nor a compression in the horizontal dimension, but we will deal with graphs that could be reflection. So if the graph goes towards the left, so it either goes like this or it goes like this, so that the end behavior is towards the left of the graph, then we're going to assign it a negative so that the x's are negative. So for the first point here, we can see that the coordinates are at 0 and 1. And so the 0 is going to correspond to the C or H value. And the 1 is going to correspond to the D or the K value. And so when we write this here, we're going to go y equals a root, and then it's going to be x, and then you can write plus 0 or minus 0, but it's not necessary, so we'll just leave it out here. And then we're going to write plus 1. Now, the reason why we're going to write plus 1 is because the 1 here is positive. If it was negative, we would write negative 1. As for the B value, because from the start here, it goes to the right axis, the right horizontal axis, then we're going to leave it positive, and so there's nothing to solve for here. Now for the second point in green here, the coordinates are at 1 and 0. And so we're going to plug the second coordinate into the y and x here. So that'll be, instead of writing y, we're going to write 0. And then instead of writing x, it's going to be 1. And so we would have 0 is equal to a square root 1 plus 1. And the square root of 1 is just 1. So we would really have just, and then a times 1 is just 1. So it's 0 equals to a plus 1. And then to isolate for a, we're going to subtract 1 on both sides. And so our a ends up being negative 1. And this makes sense because if we look at the original graph of the parent function here, if this is f at x is equal to root x, if it is flipped, if the a is 1, and this is the normal, when it's flipped along the, or over the x-axis, this graph in red is going to go this way instead. And we can see that it kind of does that over here. So it makes sense that this is negative 1 because there's reflection over the x-axis. So our total equation, I'm going to write it above here in purple, is y equals negative, and you can write negative 1 or just write negative, that's fine, root x plus 1, and that is the equation for the graph below. For the second graph, we're going to do the same procedure. We're going to look at the first point here, and the coordinates of that point, we're going to assign it to the C and the D value, or the H and the K. So here, that would be, if the coordinate is at 3 and 1, that means that when I write this here, it's going to be y equals a, and then it's going to be x minus 3, and then it's going to be plus 1. Now, in terms of the B value, since this graph is going to the right, then we know that it's positive 1, so we'll leave the B value as follows. And then we're going to pick another value that is easy to read and sub it in for y and x. So I'll take, let's say, this value here, or this point, and we could see that it's at 7 and about 3. And so we'll plug it in as follows. And we're going to isolate for A. And so that means that the A value is 1. And so our equation here, when we plug it all in, with the A value, the C, and the D is going to be Y equals 1, which you could just leave it as such. And then it's going to be X minus 3 plus 1